Let's continue with the same notebook here. We're going to keep going. There's something else called integer division. We just did it, but you can also do it with this other operator. The double division sign is actually integer division, which is division with a lot of other coding languages. So if you press Shift Enter, you do get the same result of 2. Okay, there is actually another Python type, and I personally find it very exciting. And to introduce it, we're going to go through a couple of steps. Let's first introduce variables. So you could have the variable x equals 2, the variable y equals 3, and then you could add these variables x plus y, press Shift Enter to see the result, and you can see that you do in fact get 5. You can reassign variables, so x can equal x plus 1. Why can you do this? You cannot do this in math, because in Python, variable assignments are left to right. And so if you go on the right side, well, x has a value of 2. And so this simply says we'll reassign x as 2 plus 1. And so it will be 3. We can check. Now, if you put x on the last line, it'll actually show you in Colab what that value is, and you can see 3. Now, this is so standard, this x equals x plus 1, that there's shorthand for it, x plus equals 1. And the standard way to display what variables are beyond Colab is to just print it out. So print displays the value of a variable or whatever is there. And then you can see it has now been upped to the level of 4. So let's look at the quadratic formula. The quadratic formula is x, let me make it as a comment, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, it's a bit much to write, but let's get it in here. And what we're going to do is we're going to code this up. And this is really one of the cool things about code, is that you can, in effect, write programs to do work for you that's repetitive. And so what's this a and b and c stuff? Well, that's given what? It's given that you have some quadratic ax squared plus bx plus c. So ax squared, plus bx plus c. Okay, so what we're going to do now is we're going to plug in values. We're going to let a equals 1, b equals, we'll make it simple. We'll make them all equal to 1. Okay, and how do we now figure out what x is? So we're solving the quadratic x squared plus x plus 1 equals 0. So what we do is we just need to give two answers. How about x1, our first answer? We'll take negative b plus, and now this root b squared minus 4ac is what's called the discriminant. So let's call it that. So the discriminant is b squared minus 4. And you can't write ac. It would treat that, it wouldn't know what to do with that. You've got to actually put the times in. So it's times a times c. Okay, that's the discriminant. And so what you do is you take the discriminant to the 1/2, that's the square root piece, to the 0.5, and then you put all of this divided by 2 times a. Now, if you just put in 2a, or 2 times a, the a will go in the numerator, so you've got to put 2 times a all in the denominator as such. Okay, and x2 is very similar. We can, in effect, copy it. You copy the whole line, Command-C, Command-V, change it to x2, and all we change is minus, plus or minus. Okay, that's one way to get 2 different answers. Okay, and so what we want to do now is print out x1 and x2. We're getting the solutions of the 2x values that should solve our quadratic formula problem. Okay, this is a lot. Let's press Shift Enter, see what we get. Look at this. This is fascinating. It's incredible. Like, there's a J here. What the heck is going on? Okay, is this a different type? Let us check. What is the type of x1? It's complex. So Python includes complex numbers as a type. This is beautiful. Many programming languages do not, I can tell you. And so what some programming languages will do is they will get a negative discriminant and you'll get no solution or an error, whereas this actually includes complex numbers and gives you the correct solutions. You can see the J there. And so to add complex numbers, you could have like C1 for one complex number, like 3 plus 4J. And then if you want your second complex number to be something like 1 minus J, look at the J there. It looks different. You need to put a 1 in front of it to identify it as a complex number. And then you could add them together. What are these two complex numbers? If you add them up, it's 4 plus 3J. So that's another Python type. The other way to get more in depth with using Python calculators to use the NumPy library. Let's import NumPy as NP, stands for numerical Python. When you import a library like this, okay, the idea here is it's not included because Python's designed to be fast, so it doesn't overload you with libraries you might not use. This is for math people. NP, the labeling means to access this library, press Shift Enter to store it. You're going to type NP and then dot, and now you can use any method in the library. Look at all of these methods. These are just the A's here, the beginnings of the A's. So what's all in here? I'll show you some things I like to use. There are values, np.py, okay? This is an attribute, meaning it's stored in, it's not running something. So press Shift Enter, and you can see there's the float that gives you what Python uses for the decimal places for pi. What about np.e? Okay, what is this? Well, that's the exponential 2.718 with that number of decimal places. What else do we have? You've got trigonometry like the sine function. These are in radians, okay? So you could do like pi over 2, np.pi divided by 2. If you press Shift Enter, you get the expected value of 1.0. But this is interesting. If you go into a cell, Command A, Command C, it'll copy everything in the cell. Let's just now do pi instead of pi over 2. Press Shift Enter. And look at this. If you know your trigonometry, the expected value is 0. You get this e to the negative 16, indicating that you go to the left 16 decimal places here, okay, before you get this 1. So it's 0.000, a bunch of zeros before the 1. This is actually 0, and this is standard. This happens a lot because of the algorithms that people use to write these programs that work for any given number. So if you see an e and a big negative integer after it, you can assume it is probably 0 in most cases. Okay, what else do we have in the NumPy library? There's a cool random library within it, nprandom.random. Okay, this is a function, it's a method actually, which means you need the parentheses to run it. And so if you press Shift Enter to run it, it gives you a random number between 0 and 1. So you can run it a few times, have some fun with it. Another nice random one for numbers is random integers. And so for the rand int, you start with 0. That means we're going to include 0. Let's also include 1 and stop there. That means you actually put 2 in because Python uses a standard of excluding the last number. So if you run this a bunch of times, you should get 0s and 1s. Okay, that's a mistake there. Get rid of that coding cell. And I'll try this again. Now I got 1. It's good to run it a few times to make sure it works as expected. And also a little fun, you can see how many times, was that 4 1s in a row? How many times you can get something in a row. So that's an overview of Python as a calculator. It actually is an amazing calculator. It works much better than most real calculators. You can use it to solve problems like the quadratic formula. You can use NumPy to really enhance it, use the random library. And it even Python has the bonuses of complex numbers. It's just, I use it honestly as a calculator.